Hi folks, we're going to take a look at page 438, number 8. So here it tells us that a boat took 5 hours to travel 60 kilometers up a river against the current, okay? And then return trip took 3 hours with the current, okay? And they want us to find the speed of the boat in still water and the speed of the current, okay? So you got to think here that if I'm traveling in this direction and the current is traveling in the opposite direction, it's going to slow me down. Okay, so my resultant velocity is going to be the velocity at which the boat goes minus the velocity of the current that's slowing me down. Okay, so I've got velocity of boat minus velocity of current is equal to, so what is that speed? Well, they're not giving me the speed, but they are giving me the distance and the time. And of course, speed is equal to distance over time. So this had a distance of 60 kilometers divided by 5 hours. So that's just 12 kilometers per hour. All right. Now, when I'm going in the other direction, here's the speed of my boat, but now the current is in the same direction. So it's going to be adding to my final speed. All right, so here I'm going to take the velocity of the boat and I'm going to be adding the velocity of the current because they're in the exact same direction. And not surprisingly, it's going to result in a higher total speed. Okay, because here this 60 kilometers took only 3 hours to complete. So that's going to be 20 kilometers per hour. So not surprisingly, the total velocity is going to be larger. Okay, so now what I've done is I've set up a system of linear equations, and a very easy system of linear equations, because if I just add these two equations together, I see that the velocity of the current is just going to eliminate. All right, so here I'm left with velocity of boat plus velocity of boat. So that's 2 times the velocity of the boat. Here, minus velocity of current plus velocity of current. Those cancel out. And on the other side, I'm just left with 12 plus 20 is 32. Okay, and this is how elimination works. I eliminate one variable, so that allows me to solve for the other variable. So 32 divided by 2 is just 16 kilometers an hour for the velocity of the boat. And once I have one of those, I can then input it into one of my equations to find the other variable. So I'll input it here. I could do it with first equation also. So here I have the velocity of the boat, which is 16, plus the velocity of the current is going to be equal to 20. So that means that the velocity of the current is 20 minus 16, 4 kilometers. Whoops, I already had that, per hour. Okay, so here we have that the velocity of boat in still water is 16 kilometers per hour, and the velocity of the current is 4 kilometers per hour. Okay, so let's just recap here. So this is a pretty typical type of question. So here we're assuming that we're either exactly against the current, or with the current. So when we're against the current, the velocity at which we ride our boat, okay, is going to get subtracted by the velocity of the current to give our total velocity. Whereas when the boat is set to travel in the same direction as the current, you're going to add the two in order to get the total velocity. And then from there, you just solve the system as you would any other system of linear equations. All right, that's it for this one.